in order to create effective visualizations. Okay, so we all know, data the amount of data is increasing, the quantity and the quality of data is increasing recently. And we know that being able to understand and process the data, extract insights from it is becoming an essential skill for not just for researchers like us, but also essential for pretty much everyone. And to that, a visualization, I think, provides a really approachable means of making sense of complex data. The reason that it is approachable is that it leverages our natural visual perception without requiring advanced statistical literacy. So if you compare with the other senses like touch and sound and so on, the amount of the total bandwidth for information processing is much more significant compared to other senses. So for example, if you think about like communicating this red dot among all the other blue dots, the red dot really pops out to our eyes. But if you want to communicate this same information using sound, you have to go through one by one. Here is a blue dot at the left corner, and so on and so forth. So it's a serial processing, but if you think about visual perception, it's a kind of a parallel processing. So that's one of the benefits of visualization. And as Damian pointed out, the visualization's really gone mainstream, which is really grateful for visualization researchers like us. So especially in the past, a lot of researchers and analysts using visualizations to explore and analyze data like a scientist. But also we are seeing broader audiences from different fields such as infographic design and also journalism. And also we are seeing even artists and casual users creating visualizations using their own personal data to gain insights about themselves. And in order to kind of explain the value of visualization, I found this interesting example. So this one is from very recent paper, 2020. I think it's probably published a month ago, like very recent. So what they did in this paper, they had this data set. There are 2 or 3 columns. One is the number of steps, and the other column is BMI, and the last column is gender. I think the gender column is missing for some reason. So the researchers asked students use this data set. The researchers gave specific hypotheses, and then asked the students to either confirm the hypothesis or disprove the hypothesis. At the end, what happened is interesting. It's very interesting. So students used their familiar tool to analyze the data, but at the end, more than half of the students didn't find that there is a gorilla in the data set. So what this example tells us is that we need to make both calculations and visualizations in order to better understanding of the data, not just focusing on confirming specific hypotheses. So basically, I explained how visualization can be useful, why visualization is powerful. But my question to you is that are all visualizations good? So I'd like to answer this question using some examples that I recently collected in the wild. The short answer is that not all visualizations are good. So in order to prepare this presentation, I tried to go back in time and try to collect some examples that are relevant to recent events that happened to us about the election and also the coronavirus pandemic. So I will start with a very simple bar chart. This is a that simple visualization. All of you are familiar with this chart. This is a bar chart. What do you see from this visualization? What is wrong with this visualization? Can you see? I actually don't know the NCA. It might be, do you guys know NCA? It might be a news media company, just like other news media outlets. But one problem is that the number is probably correct, but somehow the size of the bar, they don't seem to match the numbers. So frankly speaking, I don't know what's the intention of the designer of this visualization and how they actually end up creating this bar chart. But it seems like the y-axis is probably manipulated in a nonlinear way, in a deceptive way. And also probably there might be some missing zero baseline as well. So anyway, I thought this is an interesting to begin with. But by the way, feel free to interrupt me if you don't understand what's the problem here, and if you have any questions to add, any comments to add, anytime. And this is also from this year's election. A lot of people probably saw this kind of visualization. The name of this visualization is called choropleth map. It uses the land, the county, the region as a visual encoding channel to encode the data. But there is an issue to it. So I'm going to briefly explain what are the issues related to this visualization, although it's very commonly popularly used. Here is another example. So, the past president or the current president used this chart to, say that when people are discussing impeaching the president, I think he used this visualization to say that there are a lot of supporters of the president. But as I mentioned, this choropleth map is kind of hiding some details. So I'm going to explain what that is. So I found, so I'm going to use an old visualization as an example to demonstrate the issues with this chart. So this is a same choropleth map, county by county, showing the election for Kerry and Bush in 2004. It's a little bit old, and it basically shows the majority vote for each candidate. So this is probably pretty intuitive to understand. But it looks like there are a lot of red, right? But the issue is that if you look more closely, it's not actually showing the absolute number of votes. The difference between these two candidates, the number of votes, is actually around 3 million. But if you think about the number of pixels depicted in the map, the difference between the pixel amount is actually much more significant. So that's why we perceive, whenever we see this kind of visualization, we kind of immediately think that there are a lot of reds in this visualization, although the underlying data might have a different trend. So that's something that you need to be aware of when looking at this kind of map. A better way to improve the chart is to encode some additional data. So this one is actually taking into account the percentage of votes. So it's a little bit better than the one before. But still, this one has a one issue, which means still we see a lot of red here. The size of the land is kind of exaggerating the data, underlying data. So that's a one issue with this choropleth map. So I found that a lot of news media outlets like New York Times are no longer using this visualization, which is good. So a better alternative is to use a symbol map. So you separate the land, you create another layer, and then you create a circles and use each circle to encode the data. So your data is kind of separate from the land side, but you still see the geo coordinate of each circle. So this is one alternative to improve based on the choropleth map we saw before. Another alternative map is what is called, I don't think there is a name for it, but this is a grid map, I think. It's basically a cartogram using shapes other than length to encode the data. And this visualization directly visualizes the number of electoral votes. So it's separate from it's not distorting the data based on the land size. So I found that these days the news media companies are doing a little bit better than before. So I tried to collect some visualizations from different news media, from Economist to CNN. You see, Economist is completely discarded choropleth map. It's just using the symbol map. Bloomberg is using the grid map. But still, a lot of news medias are using choropleth map. I think these are the fine. These are okay, I think, because in this choropleth map, what we care is probably whether each state won which candidate or not. So this might be fine. But I found that Fox News is the one that's still using this county choropleth map, which I found quite kind of interesting. But anyway, it's getting better. I think the companies are doing better than before. Another map, this one is about coronavirus cases. I thought that I found the strong use of color quite interesting. I'm not sure if this is a good idea. The color scale is good. First of all, it's a non-linear, so it might be a little bit difficult for a lay audience to understand. And also this yellow somehow like really pops out. Somehow it feels bigger than the red for some reason. So maybe it is not using the right saturation level. But another problem, a bigger problem that I see is that is the projection. So this projection, the map visualization, this one is called, is using the Mercator projection. It's the most common projection people use. But every projection method has an issue because the projection is about transforming a sphere into the visualization on a flat screen. So no matter what, every projection kind of has to distort the lens size in order to project a 3D sphere into a two-dimensional space. In the case of Mercator projection, the lens far away from the equator line tend to be exaggerated, like European countries and especially Russia. It looks huge. And also United States a little bit bigger, but if you pull the United States close to the equator line, it becomes a little bit smaller. So as you can see from this figure, Africa is actually bigger than these three countries combined. So that's another issue you need to pay attention. Oops. Oh yeah. I will try to share the slides later on. You can actually try this too. I can try one country, like for example, when I was a kid, I always thought that Greenland is such a huge country. But if I drag this green line, it becomes really small. Yeah, I thought that this is funny. Here is another map. This one is also using a wrong color scale, I think. When you encode numerical data using color, it's better to use like a simple linear color scale using saturation. But this one is kind of using multicolor. For some reason, the designer is using the lighter color for the highest number of cases. So it's kind of misleading. And this one is from MSNBC. It's a credible, I thought it's a credible media company, but still making this kind of mistake. This one, another visualization about coronavirus, which I found really hard to understand this chart. You also need to pay attention to this one. The dates are okay, but somehow the numbers and the length of the bar, they do not match. I have no idea actually how they created this chart, using what kind of method. It seems like the y-axis is completely manipulated. And another one from the public health department in the Georgia state. I mean, it looks beautiful, it looks fine. Can you identify which one is wrong? I am curious whether you can figure the problem out. So if you look closely, like look at the x-axis. It's kind of a, I don't know, they kind of cherry pick the dates and then ordered in a random way so that in order for the graph to look like a decreasing trend. So again, this is from, as far as I know, this is from the public health department in the Georgia state. And they are making this kind of deceptive graph for the public. Another visualization that I found, when I first saw this visualization, I was really stunned about the complexity of this visualization. The y-axis is the average number of deaths per day, and the x-axis is a diverging scale. So there is a midpoint, 0 point, and if the lines moves to the right, it means it's increasing, and if the lines moves to the left, that means it's decreasing. And the line itself starting from here, and it is in the chronological order. So this one is the start date, and that is the end date. So if the line moves to here, it's increasing. If it goes back to this one, then it's decreasing, and so on and so forth. I thought that the visualization itself is quite interesting, but I don't know whether this visualization is actually good for the public. Even myself, I had a hard time understanding this chart. So it turns out that somebody actually transformed this chart into a line chart. In fact, it can be actually the same data can be represented in a line chart, which is probably much more familiar and intuitive to many people. So this line chart is actually correspond to this tornado plot. So that's what people call tornado plot. To me, as a visualization researcher, I found this visualization interesting. There might be something benefit to using this visualization, especially it is trying to show the derivative, like the differences, the increasing and difference, the differences in increasing and the decreasing. So there might be some benefit to it, but I think for the public, I probably wouldn't use this chart. Another one from Massachusetts. So I'm checking the coronavirus cases daily. So I got this from, this one is also from the public health department in the Massachusetts. The reason that I found interesting was that the strong use of red and the green color. I mean, this is probably okay for most people, but actually there are a lot of people who are colorblind, especially red and green colorblind. So I tried to run this visualization on a colorblind simulator, and this is what I got. I mean, if you pay attention to the legend, it might be still understandable for colorblind people, but if you just look at the visualization, it might be misleading in a way that it looks like it is using like a linear color scale to colorblind people, not like this multicolor diverging scale, but it looks like a linear scale. So that's something you need to be careful when you create a visualization with a strong red and green. You also need to take into account people with a visual impairment. So this one is the last example that I want to share. I tried to look at the dashboard from our neighborhood university. This one is BU, not BC. I don't know. What do you think? I thought there is nothing wrong with this visualization, but I found this is just a weird visualization. If you look at the legend, there are both negative tests and there are positive tests. And I actually went to the website and I checked that there are some positive tests in this bar, but it's just not visible because the number of positive tests is so small compared to the negative test. So I don't really see the point of this visualization. What's the message of this visualization? I probably would create a separate chart for the positive test so that we can actually see the trend, whether it's decreasing or whether it's increasing. I found that probably the administration trying to, kind of hide the positive cases, I think. So I shared a couple of visualizations in the wild that are not well designed. Then we can ask a question, what makes a truthful and the functional visualization? So I'm going to talk about, how as a visualization researcher in our field, how we conduct evaluations in order to find the effective, in order to find design principles for effective visualization design. Before that, I created this. I want to give you like a primer on the basic science behind visualization design. So if you don't mind, we can actually do this experiment together. You can actually use the chat window to type your answer. What I'm going to do is that we're going to basically compare the bar chart and the pie chart. And then we're going to go through a couple of questions. And each question will ask you to find a certain item in the chart. And then you need to try to answer the question as fast as possible and as accurate as possible. So I'm gonna try to watch out for the chat window. And then you can try to share your answer in the chat window. Okay, let me start. Can you actually see it? It's probably too small. Let me increase the, can you see the screen well? Okay, I'm gonna start. So which one is the third largest segment in this pie chart? Oh, okay. So many different answers. I'm gonna just use the first answer, F. And again, finding the third largest segment, I will just use the first answer. A. What about now? Again, A. Okay. Oops. D. Okay. One more. E. Okay, great. Okay, so we got two questions right. Yeah, I mean, that's a little bad, I think. So let's try another one. We're gonna try the same one with the bar chart. So let's try this one. F, okay. What about this one? Again, F, D, C, D, okay, D. And the next one, F, all right. And the next one, D, okay. And this one is the last one, F, okay. 5 out of 5. So that's great. Let's see. So for the pies, you guys are a little bit worse than the average. But the bar charts, you guys are better than the average. So which is good. So now you can see, you can compare pie chart and the bar chart based on this accuracy, based on this perceptual task. So that's the sort of the basic science stuff that people have been doing so far. Although there are more to it, more factors other than perception impacting the visualization design, but this is a basic way to evaluate different kinds of chart. So now you have a better idea how we can actually choose a better chart in a scientific way. So I'm going to talk about three of my projects, and then talk about how we evaluated each one of these. I'm going to talk about three different types of project. One is the technique, creating a new visualization technique. The other one is empirical study about understanding how people perceive visualization. And the last one is developing a new kinds of visualization systems and tools to enable people interact with data in a novel way. And then for these projects, I will talk about different evaluations for how we evaluate each different project using different evaluation. So the first one is a technique paper. It's a little bit old paper. I worked on this paper 2010. It's about 10 years ago. So we developed the visualization technique for genealogical data. Damien briefly shared this visualization. So you're probably familiar with the standard family tree where you see the structure of the family. We try to add additional dimension to the visualization by adding a temporal dimension to the visualization by encoding each individual as a timeline. So here, this is actually my own family tree. Each line indicates each individual, and when the lines converge together, that indicate the marriage. When the lines diverge, that means divorce, and the drop lines indicate the parent-child relationships. And also we try to encode some global events like Korean War and also personal events, directly embedding the events onto each timeline. Just to explain the visual encoding, so here is one example showing the marriages of the actor Elizabeth Taylor. You see a lot of marriages and also a lot of divorces. So we found this is interesting, so we decided to include this figure in the paper. And here is another one showing the marriages of Osama bin Laden. As I mentioned, this is an old paper, so back then it was interesting to see this visualization. So you also see a lot of marriages, but less divorce. And also in terms of visual design, we also try to incorporate these gradient things in order to communicate the uncertainty in the data. So I'm pretty sure that the visualization design should be intuitive to you. Otherwise, feel free to ask questions on the chat window. In terms of designing this technique, we also experiment with different options for visual encoding design. So our visualization design can actually communicate the child out of wedlock. And also we experimented with the different visual design using the drop lines or extending the parent lines to show the children. Although we decided to use this one. Mainly this one is more visually compelling, I think, but this one is probably more perceptually accurate. Under the hood, in order to develop this technique, we also come up with a new layout computation. This is probably not relevant to most of you guys. Basically, it's a tree visualization with some kind of customization. This is a family tree for the royal family in the UK. And this is how our layout computation spatially arranged the timelines. So anyway, I'm not going to go into the details of this kind of stuff. So the last thing I wanted to mention about the technique is that our layout is also can adapt to different sizes of screen. So let's say given this visualization, if your screen is limited, like let's say you are using a mobile screen or something, then we actually automatically filter unimportant data. So we are actually using some kind of modeling technique in order to model each item's degree of interest. And then we filter items based on their degree of interest in order to adapt this visualization to a smaller screen. So that's a brief introduction about the technique. But I guess our main question is that how do we know TimeNet is more effective compared to standard family tree? So in order to evaluate the effectiveness of TimeNet, we kind of ran a similar study, just like we did for the pie chart and the bar chart. So in this case, we compare this TimeNet to a standard family tree diagram. So in order to make the information same, we extended the family tree diagram in order so that we can incorporate multiple marriages. So it was a little bit awkward, but our intention was to make sure that information is the same and reduce the confounding factors in the experiment design. So we compared these two visualizations, and then we come up with the specific task questions. One set is related to understanding the structural aspects of the family tree. The other one is related to the temporal dimension. The last one is basically a combination of both. And then we try to measure time and accuracy for these questions. So in terms of, we also, just like any other experiment, we come up with a hypothesis. So the first hypothesis was that the traditional family tree diagrams might support faster and more accurate perception of the structural family relations. On the other hand, our natural hypothesis was that time nets may better facilitate the understanding of the temporal patterns, because that's what we came up with this new technique. And we recruited around like 22 subjects in Amazon's Mechanical Turk. The study design was within subject design. And we also had some kind of qualification task because we are recruiting crowd workers, random people on the web. So we wanted to ensure the quality. And then, as I mentioned, we tried to measure the time and the accuracy for each task question. And the results, we didn't find any significant difference in terms of accuracy and time between the family tree diagrams and the time nets. So that, actually, wait. So there's a typo. So that doesn't support first hypothesis, because we assume that standard family tree diagram might be better than time net, but we didn't find any significant difference, which is good for time net. On the other hand, time net, we found that there is a significant lower response time, especially for the temporal questions. So in a way, that actually partially support second hypothesis. Yeah, so I'm pretty sure you guys are familiar with this kind of experiment, just like any other like a social science experiment. So we also do this kind of experiment in order to find which visualization is more effective. So I'm going to transition to the second project. By the way, feel free to ask questions on the chat window. The second project, I was a main collaborator for this project. And it goes beyond simple graphical perception. As I mentioned, there are other design factors impacting the visualization design. It's more than time and accuracy. So in this project, we try to investigate cognitive design dimension, which is memorability. So our main research question was, what makes a visualization more memorable, beyond time and accuracy? So this is a rough experiment procedure. I'm going to briefly explain the procedure and then share the outcomes of the result. So we started with this is the experiment stimuli. So we started with the labeled visualization database. We had roughly around 400 visualizations. And in order to analyze the experiment results more rigorously, we actually manually segmented visualizations into different parts. So we know where is the title, which one is the title, which one is the label, which one is the visual marks, and so on and so forth. So we had all this kind of information. And this is mainly for eye tracking. So in the first step of the procedure, we had the encoding phase, which means we show each visualization for 10 seconds for each participant. It was mainly a free-form reading and exploration. But while participants are reading the visualization, we try to run the eye tracking and try to track the eye movements of the participants. So that was the first step in the procedure. It took around 20 minutes. And then the next step is that we show the same set of visualizations in different order. We only show each visualization for 2 seconds. We also track the eye movements as well. And we ask the participants to press the space bar if they recognize the visualization, if they recognize the visualization, if they think that they saw the visualization in the encoding phase. So in this way, we can actually compute the memorability, right? Like a short-term memorability in a way. And the last step was that we show, again, in this last step, we show the successfully recognized visualizations, but we actually blur the visualization to hide all information. And then we give 20 seconds for each participant to explain, to describe the visualization purely based on their memory. Because we blur the visualization, they don't really see any text in the visualization. They have to rely on their memory in order to describe each visualization. So that's the experiment overview of the experiment procedure. I'm going to briefly share the results of the experiment. which was really well received in the field. Is really probably useful for you as well. So here is the eye movement patterns in the eye tracking encoding phase. We separated into most memorable and least memorable visualizations. There are not much difference in the eye movements across these visualizations. But what is interesting is that if you look at the eye movements in the recognition phase, you see a very different pattern. For example, for the most memorable visualizations, you see a clear center bias, right? This means that participants were able to press the spacebar immediately when they see the visualization. So they don't really move their eyes, but they just hit the spacebar because they immediately recognize the visualization. On the other hand, for the least memorable visualizations, the eye movements are basically across the visualizations, which means they try to look for some kind of cues, whether in order to decide whether they recognize visualization or not. So that's why they are looking for, visual cues. You see a lot of scattered eye movements in these visualizations. So what we can learn from this is that there is a strong visual associations in memorable visualizations. On the other hand, for the least memorable visualizations, people are trying to rely on semantic associations like the title and the description of the chart in order to decide whether they recognize each visualization or not. And also, we had a description stage, right? So we asked people to describe the visualizations at the end, and we analyzed the descriptions, and then we basically manually coded, which element people mentioned in the last step. And we found that a lot of people, they mentioned titles and also label and the paragraph, but the title was the top. That means that a good title is actually very important. Having a good title is really important to make your visualization memorable. And also we manually encoded this quality of the description. So here we arrange the visualizations based on the description quality from low to high. And also vertically, the least visualization, least memorable and the most memorable at the top. So the most effective visualizations basically lies in the first quadrant. And they have a strong visual associations. And also they have a good semantic associations, which means they have a good title and good descriptions. And there are also other factors that make these visualizations more memorable, which I'm going to explain in the next slide. So, okay. So I try to prepare some examples so that you hopefully these examples will be useful for you when you create a visualizations. So here is an original chart showing the gender equality in labor force participation across different Asian countries. And the y-axis is the ratio of female to male labor force participation. I mean, this is an okay chart, but we can actually improve this chart based on the outcomes of the experiment. So for example, we can do a redundant encoding. We can add labels. We can also add the pictograms and descriptions of the chart. In a way, this kind of add a message redundancy. So you can compare which one is kind of more memorable. And here's another chart showing the life expectancy and in the y-axis and the economic growth in the x-axis, also for the same countries. This one is also okay chart, but we can also improve that by adding a data redundancy, by redundantly encoding the GNI using the size of the circle. We can also add a message redundancy, adding a description and adding an annotation as well. And you can compare which one is more effective. Here is another one showing the female students in computer science compared to other science majors. This one is also okay chart, but based on the lessons learned from the experiment, we can also add a pictogram to make it more compelling. And this one is showing the insurance rate in the United States. This one, The reason that I think the title is not good is basically just describing the dimensions of the data, nothing else. But you can actually make this title more meaningful by encoding your message into the title. Okay, so that's the second project. I'm going to move on to the last project, which is a tool that we developed in order to help infographic designers. It's called Data-Driven Guide. So there are a lot of visualization tools these days. You guys are probably familiar with the Excel, and maybe some of you heard about Tableau. I think Tableau is getting popular. There are some tools, you probably don't know this tool. On the other hand, so a lot of people use this Excel and Tableau to create visualizations, but also there are like designers who use these graphic design tools, vector editing tools, to create a more compelling and customized graphics. And I thought that there is some missing piece here. So this project is basically investigating this gap between these two spectrum of tools. So evaluation I did in this research is basically needs finding research. What I did is that in order to, what we can do to fill this gap, we basically do like a interview study, or what sometimes we call contextual inquiry. So I basically went to the Northeastern University, the design program, and I tried to talk to students there, 3 master students. Some of them already had some professional experience. So I basically tried to talk to the design professionals. Most of them, they had like years of experience in graphic design and infographic design. And mostly they use vector editing tools like Adobe Illustrator in order to create like a custom infographic or data-driven chart. And the goal of this evaluation, it's not an evaluation per se, it's more of like a formative study. So I had a set of interview questions. I tried to, understand their overall design process because I'm not a designer. I basically try to identify how the needs of what they're doing. So I also try to understand the difficulties they face when creating this kind of data-driven graphics. And especially I was interested in how they actually use Adobe Illustrator to create a data-driven chart. Essentially how they manually encode the data into the graphics. Because the tools are not designed to support, creating data-driven graphics. And also, what are the motivations for, manual design practice? Why not just use Tableau? Why not just use Excel? Why do you use Adobe Illustrator? So those are the interview questions that I did to understand the current design practice. So I learned that, like using this kind of pre-existing tools, their creativity, their flexibility is limited. So it's difficult to add annotations and embellishments in Tableau. Right now you can do it, but it's actually still very difficult. And there are other tools like this one, which allow more customizations, but still, it's difficult to, customize, design a new visual marks or design a new layout. That's actually not possible in this kind of tool. On the other hand, there is a problem with their own tools as well. The Adobe Illustrators, as I mentioned, they do not support data-driven design. So what they did was kind of interesting. So they actually drew this ruler by themselves in order to measure graphics based on the data. So I found this problem is interesting. So I thought that we could actually develop a tool to solve this problem. So based on the formative study user interview, we identified the design goals of our tool. The first one is to maintain flexibility in the design process. And the second one is to provide methods for accurate data-driven drawing. This kind of hand-drawn ruler is probably not accurate. And then we also wanted to support more persistent data binding for freeform graphics. So in this one, there is no binding between the data and the graphics. It's all manually crafted. So we wanted to actually provide a data binding for the graphics. And then we develop a design tool in collaboration with Adobe. So this is what our tool looks like. And this is the visualization that we created using the tool. I'm not going into the details about the technique because that's not probably what you're interested in, but I will basically briefly explain the concept behind the tool. So given a data table, our goal is not to create like a predefined bar chart, but we wanted to create just produce a data-driven guides where designers can draw their visualizations with the help of the guide. So that's the main concept behind this tool. So that's pretty much it, but I prepared the video, but I don't know if I have time to play one. It's actually 48 seconds, so let's watch this one. So this is I'm not gonna explain detail, but this is the data-driven guide, and they can draw their own shapes on top of the data-driven guide. So it's much better than manually measuring the graphics because they already have a data-driven guides to refer to. And here creating a flower chart using the well-being index data and draw their own custom visuals on top of the data and then color coding the flower. And you can simply copy and paste this flower and then update the data binding. And then the flower will automatically update based on the data. So this is much different from the Excel, right? And I also prepared like a really extreme example, like creating this monster graphic. It was the reaction was really controversial when I presented this in the conference. So let's watch this. So I imported this monster graphic and I put the hypothetical data here and I tried to repurpose the teeth based on the data. Yeah, and then generating data labels. And then you can actually create multiple monster charts, just copying and pasting it. And then because we have a data binding, you can just update the data and then the teeth will automatically update based on the data. Some people really hated this example, especially who are really like data sciencey stuff. But anyway, a lot of people like this example, I thought. That's why I thought I would like to share this with you as well. Oops. Yeah, so actually, I mean, it was really controversial system, but actually it was well received by the practitioners. And one of the participants, we also ran an evaluation study after building this tool. Very simple evaluation study. Basically, I asked them to use the tool. I prepared like materials, tutorials, and I just wanted to see how they use this tool, measuring the usability of the tool. And one participant mentioned that, exactly mentioned why we created this tool. They need a calculator to make accurate data graphics, which is right now is pretty obvious. And this tool makes it much easier to try things out and experiment with the graphics because it supports the data binding. And here are some examples that they created during the usability study. So in this talk, I talked about 3 different projects. One is a technique paper, which is about graphical perception. And the second study was more about cognition, using eye tracking, understanding memorability of visualizations. And the last one is more about needs finding, formative study, not an evaluation, but how we actually develop novel tools, novel interaction tools by understanding these people. And so I also do other types of work as well, but mostly techniques and systems. So here is a kind of a screenshot of all the work that I did during my PhD and also before. And that's all for my presentation. Thank you.
Thanks, Tom. That was a really fun and enjoyable look through all kinds of different data visualizations, and then really looking under the hood and how we design and understand what's quality in these tools. So I'm encouraging everyone to put comments and questions in the chat. You can also unmute. We're a pretty small enough group. We have a few minutes if anyone has any questions or comments. Larry noted the work fits really nicely with Huff's, he was a journalist in the 50s who wrote How to Lie with Statistics, and then moving forward into the 80s with, I know you're familiar with Edward Tufte's work
Yes.
on the
Yes.
visual display of quantitative information. Yeah, so it's just great to see those connections.
Yeah, this is really cool, Nam. Thank you very much. This fits into the type of work that we do. We're always trying to figure out how to make what seems to be relatively complicated statistical material and output at times more understandable to our clients and colleagues. So I love it. I'm so pleased to see computer science bring someone, yourself in particular, into the department over there. Your contribution to departments all over the campus is obvious to me. And this is something that we should be able to work out some type of academic collaboration with. So thank you very much. This was good. Let me turn it back over to all the rest of you here.
Yeah, I mean, Larry, one of the topics or issues that pop out to me, just thinking about test construction, is the research that Nam was doing, looking at how changes in the display changed or impacted people's understanding.
Yeah.
And then thinking about on a test question, when we include a graphic, how, oftentimes we're using the graphic to test as a representation of data or information that is actually the focus of assessment. But if the way in which the information is being displayed impacts people's understanding,
Yeah.
it could add an interesting construct or relevant aspect to it. It's
Yes.
really interesting.
Yeah.
Yeah,
I
exactly.
have a quick question I want to ask Nam. Hi, Nam.
Sure.
This is Mandy. Good to hear your presentation. It's beautiful and very impressive.
Thank you.
Apart from what Mike Russell just mentioned, that we can incorporate quite a lot of information in our assessment design to make our test with rich information and with more options to let students to explain their thinking process. Apart from that, I want to ask you, we are doing a lot of the statistical and modeling work, and one of the components in our report is to show effective results and show our models, show our analysis results, and with the visual display. And quite a lot of your work, you are doing software design and you provide tools for other people to learn. And for us in statistics, we not only learn the software, the tools to make it fit into our work. Ideally, we hope that we can develop or have the capability to develop tools and combined with our simulation work, combined with our models to present some of analysis results. I see you have quite a lot of visual communication theory incorporated in that as well. Apart from your computer science, lots of programming, coding, those knowledge. Mm-hmm. If our students want to incorporate all of this into their learning, combined with our statistics degree, what are the core courses you think will help our department, will help our students? Visual communication is one thing I can think of. And, the programming, our students do not get trained like computer science students to have 10, 12 programming courses. Mm-hmm. What are the core courses you think will benefit our students when they are finishing their degree?
In terms of understanding this kind of visual communication stuff, I'm teaching data visualization. So mm-hmm. I would love to, have some students from education department, although my course right now is an undergrad course. So I was actually discussing this with Damian and Larry, because I want to make my course accessible to as many students as possible. But for some reason, our department right now have so many students want to take computer science course. So, but anyway, I guess in order to answer your question, there are a lot of, in many schools now, there are many data visualization courses dedicated to teaching this kind of stuff. So I cannot recommend anything else because there is already a dedicated visualization course. Does this answer your question? Or?
Do you have a prerequisite, for example, in order to, you are just teaching students to use tools, to choose tools do you teach students to develop tools to fit their work? Do they need to do programming? Do they need to do lots of computer science algorithms?
So right now, yeah, that's exactly. So right now I have a one prerequisite, which is CS1, which means you need to have like a basic, really basic programming skill. I think our department used Python as a primary language for CS1. So that's a prerequisite. But I mean, thinking ahead, eventually in the few years, if I want to make my course available for students outside computer science, I've been thinking about, I've been constantly thinking about dropping the prerequisite and then maybe reducing the programming, or actually they can choose different tracks. You know, they can use Excel or Tableau so that they don't really need to do programming. But computer science students, they can still do programming to do some building stuff. So
Yeah.
anyway,
Is there any option to make it a graduate level course? Because
I'd love to. I would like to, talk to our department chair to make our visualization course more accessible. Because I'm actually from, I got my degree from Harvard, and we had a visualization course there. So I can briefly explain who take the visualization course there. So based on my experience at Harvard, all kinds of students, they take the visualization course. Some people from government department, some people from like English, some people from history. So I would like to, make it happen here as well. Make my course more broadly.
Yeah, I do look at data. Data visualization is part of key skills in data science field. Apart from statistics, machine learning, mathematics, communication. Part of the communication skills is data visualization, and apart from data visualization, and you have the communication theory there as well. So that's part of standard communication, modern days communication sets of tools. And for any degree, graduate degree, you also need it. It's quite popular and demanding nowadays. So thank you very much for the wonderful talk, and hope we get to know each other more and work on some projects together. And I'm going to go to teach very soon. So very nice meeting you, and welcome to our department. Yeah, I'm one of the faculty members here. So good talk to you.
All right, thanks for coming.
Yeah, and thank you, Damien, for organizing this. Really appreciate it. Okay, bye everyone.
Hi, Mandy.
Yeah.
Other questions, other interactions here with Nam? We have the time here if you want to continue. Yeah.
Yes, I want to add my thanks to Damien and to Nam. This is really interesting, and I've had long association with Howard Weiner, who of course has done a lot of work in visualization. And I think the idea that you started with, the idea of how to make data and evidence more accessible to the general public is really, really important, particularly these days. And of course the question of how you can slant visualizations as you can statistics to create an impression that is misleading, of course, is an ongoing problem. I'll just end with, I've got to leave as well, but I'll just end with a wonderful quote that I got from Howard Weiner, and he was quoting some British statisticians from the 19th century. And the quote is that extracting information from a table is like trying to get sunlight out of a cucumber.
Yes, that's a good one. I've heard that one too.
So thanks very much. Have a good afternoon.
You too.
Henry, you still there? No. Damien, you muted.
Any other questions or?
I think I have one actually. Hi, thank you for your awesome presentation. I work in IR currently, and I am interested in learning some of the tools that you demonstrated briefly, especially about, like, for example, like the monster thing. Like, can you give us some of those names? We can look it up and try out.
Yeah, although I wouldn't recommend the tool for serious data analysis, the tool is available on the web. So I will try to share the slide with Damian so that Damian can share the slide with other people.
Thank you.
We recorded the presentation as well, and we'll be making the slides accessible, I think, or that's Nam's website, which we linked to at the very beginning, and we can put in the chat. We'll also give you just an overview of a lot of the projects he's done and examples he's given. You can go in and dive deep and check them out.
Damien, thank you again. Nam, thank you again. I look forward to more of a conversation and collaboration with you all. Thank you all for coming. It was a good session. Nice going. We ought to be having one of these every week.
Thanks for inviting me. Thank you.
You're very welcome. Our pleasure. All right. Signing off now to everybody.
Take care.
Bye-bye.